Hello, 7th graders. Welcome to 11.3. Starting on page 582 of your textbook, I can construct and interpret circle graphs. Big part today is interpreting circle graphs. Yes, we're going to attempt to construct, but it can be a little bit challenging. It is very important, though, that you know how to read a circle graph and understand the meanings in it. So please follow along. Print the notes from Moodle. That would be really helpful for you to do that before we begin, to keep you a little bit more on track and a little less for you to write and have meaning when you could go back to it. So circle graphs. Circle graphs are used to compare parts of a data set to a whole set. So like we've seen before, we always like to compare a part to a whole. And we're doing that with circle graphs when looking at percents of a circle and things like that. So a circle graph should have data that add up to 100% because we know a circle has degrees up to 360. So 100% of a circle would be 360 degrees. So if you construct a circle graph from percents, so if you're given data, for in this case, this is annoying behaviors at a movie theater, 73% of people think someone talking on the phone is annoying, whereas only 3% say that someone eating loudly on a snack is annoying. And this is out of a survey of 1,100 people. So what we would do to construct a circle graph is use a percent. So since the circle's out of 360 and our percents add up to 100, we can multiply each percent by 360 to find the number of degrees for the circle graph. So for example, if 73% of people think that talking on the phone is annoying, that's the same as 73 hundredths. You just move the decimal 2 to the left. 10% say ringing cell phone's annoying. We change that to a decimal and multiply, and we get our degrees on the right. Percent change to a decimal. Percent change to a decimal. Percent change to a decimal. Remember, these are approximately, so this came out to be a decimal, like 4% of 360 was 14.4 degrees. So we rounded to make it to the nearest degree. What you could do too is use a proportion. If you really wanted to, you could do, well, 10 out of 100 is 10%. And that's the same as how many degrees out of 360. Then you would use your cross products. And then you would divide to get your variable alone. You would end up with just 36 degrees of a circle is 10%, just like we did up here. Either one really does work. I prefer this method up front because it's just a quick move the decimal and multiply rather than multiplying and then having to divide again. So how you would make a circle graph is you'd use a protractor compass to section those out. So you'd find 11 degrees of a circle, and then you would mark those off starting with your radius. So you'd start with the radius and then do the percents. This is about 3/4 of a circle, which makes sense, and it shows that there. We'll do a little bit more of this in class. So that you can give this part a try, finding the section of a circle. We're not quite finding the percent. We're given the percent. So we're finding the sector of a circle. Okay. So what we see is that we know China is 19.3% of the global wireless subscribers. So we change that to a decimal by moving the decimal 2 places to the left, taking that of 360. If we were to round these to the nearest degree, we would round that to approximately, we could say 69 degrees. I'm rounding for the first time today. 9.9% is the same as 99 thousandths. And then we're doing that times 360 because we're looking for the percent of a circle, percent of degrees of a circle. That's approximately 36 degrees. I know this pen is not pretty. Bear with me. Russia at 5.6%. We change it to a decimal. Of a circle, percent of a circle. or approximately 20 degrees. Japan at 46 thousandths of a circle, which is approximately 17 degrees. Don't take my word for it. Use your calculator too. Brazil at 4.1% of a circle. It's going to be about 15 degrees. And then other, 56.5% of the circle. We know it should be more than 180 because it's more than 50%, more than half. Approximately 203 degrees. So, and I rounded. The first time I did this, I didn't round, which might make a little bit of a difference. You have to be careful with your rounding too. You do all of your sections. If you have 100% of data, then all of your sections should add up to 362. So if I added my percents up here, I would get 100%. And since I did all the percents of a circle, all of these degrees should add up to a full 100% of a circle at 360, and they do. So then you would use a protractor, measure those out. So like, for example, I'd start with my radius. I'd start a radius at the center. I can do that. We'll try to, things in the way. Radius. And so one of them, you know, was 20 degrees, for example. So then I'd go from 0 to 20, make a mark there, and I could turn my, dang, this is going to not cooperate very well. And that should make a line there at 20. I wanted to make a line. This protractor is a little tricky, but so then you'd go on and then you'd use that as your radius and continue on to fill that in. We'll do that more in class. So when percents are not known, you have to first determine what part of the whole it represents. So if you don't know the percent, you have to find the percent and then find the section. So for example, in the Olympics, finding out which countries had the number of medals. So you have to find the total number of countries. So I look here and I see that 12 countries had between 1 to 5 medals. 3 countries, no, it's between 2 and 4, had 6 to 10. 5 countries had between 11 and 15. 1 had between 16 and 20. 4 had between 21 and 25. And 1 had between 26 and 30. Remember, this is a histogram. We learned about these. It's important to be able to understand and read data. So we find out that 26 total countries have been surveyed or counted. So then we have to find the ratio that each medal to the nearest. So the number of countries that got 1 to 5 is 12 of the 26 countries, or 46 hundredths, or 46%. 3 of the 26 had 6 to 10 medals, which is 12%. 5 of the 26 is approximately 19%. 1 of 26 is about 4%. 4 of 26 is about 15%. And 1 of 26 is about 4%. So we use these ratios then, which is our percents. Those are really our percents in decimal form, to do the number of degrees, just like we did. So the number of countries 1 to 5, about 46% at 360 is 166 degrees. 12% of a circle is 43 degrees. 19% of a circle is about 69 degrees. 4% of a circle is about 14 degrees. 15% of a circle is about 54 degrees. And 4% of a circle is about 14 degrees. Again, all of these percents should add up to 100. All of these degrees should add up to 360. So we use our compass or protractor to create this. And yeah, 46 is about half. 19 is a little under a quarter, and so on and so forth. So we fill in and label with percent and what the intervals represent. Okay, so lastly, then giving this a try. Find the percent of people born in North America. So to find the percent, we need to know a part over a whole. And we're looking for North America. So I look, I need this data. So the part in born in North America, 829,442. Out of, we need the total number. So we need to add all these up. And we end up with 31,107,500 573, and hopefully my calculator addition is not off. So we do that, we end up with approximately 0.026, and it goes on with different digits. So I would say that's approximately, as a percent, 2.6%. Move my decimal 2 to the right. Then the question's asking how many degrees of a circle would people born in Asia take up? So we need this number as our part, 8,226,254 out of the total number of people, 31,107,573. When I do that, I get approximately 0.26 things, which that is the same as 26%. So then I take what is 26% of a circle, since I'm looking for degrees, and I get 93.6 degrees. And again, interpreting data then, if you were to look here, you just have to describe the makeup of a school enrollment. It's not telling you what percent, it's not asking specifics like what percent is in kindergarten, how many people is that. It's just saying describe what you see. And just at first glance, I see that elementary school is almost 50%, but not quite. I see that college and graduate school and high school are similar, and nursery school, preschool, and kindergarten are close in numbers too. So a synopsis of what you see could be described as this. The most people described are in elementary school. That's 43.9%. The majority of people are there. 3/4 of the program is combined in K, right here, starting here through 12. That's about 3/4. That's one way. Or you could say the number of people in high school is about the same as the number of people in graduate school. They're like 1 4/10% off, just like nursery school and kindergarten are 1 1/10 off. So just ways to describe. So again, it's really important that you know how to interpret it. We'll go a little bit more over how to create it with a protractor, but being able to describe what you're seeing is very important. So rewatch, take some good notes, use personal tutors, whatever is going to be best for your learning.